As we said, my research is in astrophysics. So I work on observational astrophysics, and I'm interested in nearby galaxies and how they form stars, sort of the process through which they turn cold molecular gas into stars and how that happens differently in different types of galaxies depending on the physics. 7 years I've taught across the physics curriculum. That's one thing that makes our department different, is you'd find that it's not just one professor teaching the same course again and again. We keep it fresh by mixing up what courses we which I think is a good thing, because then you come back to a course after a few years and you sort of have new ideas about it. And I do think that keeps things nice and fresh and keeps us excited about the courses we're teaching, which has good benefits for everyone taking our courses. The only slide I wanted to share is going to be just like the very bare bones take on what is the physics major at Reed. And it's going to look boring, but it helps me kind of explain things to you. So I'm going to slide share that, share screen, share the right thing. All right, can people see? Okay, and I think, can people still see, or did that? Yes, okay, great. So this is just the very basics of, okay, I may be interested in physics. How would it work at Reed as opposed to some other place? And just the courses probably aren't wildly different. Probably college to college, the sort of backbone courses in a physics major are probably largely going to be the same. If you're deciding between Reed and other places, we'll have the intro year of physics, physics 101 and 102. And the math courses along with that, calculus and analysis. Some fraction of our intending to be physics majors get credit for the calculus course if you've already had a lot of experience in that, maybe about half, and it works whether you have or have not. And then in the second year, you're still sort of taking physics courses and math courses. Physics 201 is a particular course for it's sort of math methods. And here's maybe a little bit of something different than Reed, because Reed math is really great, but it's really mathy. And so it really serves, like, from the very beginning courses in math, it serves like the interests of the math major, which is like being good at proofs and learning the details of theoretical mathematics. And we in the physics department are super psyched that is part of everyone's knowledge going into the physics major. But in physics, we need to do a lot of applied math. And so this is kind of, Physics 201 is actually kind of an applied math course where we give you a lot of those skills, which is titled as a physics course, but has a lot of math in it. The Math 201 is linear algebra, and then 202 is vector calculus. Very key for physics, but again, in the math major vein, it's very sort of theoretical mathematics, vector calc, and so you'll find a lot of that content echoed in physics courses in a more applied way. The junior year, the third year, is really when you sort of hit full stride into physics courses, and you'll see 3 different things. I know the numbers won't mean anything to people so far, but that 311 is classical and upper level classical mechanics course. You'll have had sort of the 101 version of mechanics in the first year fall, but this takes it up a serious notch, and you need the math background before tackling it. Similarly, 321 is upper level electricity and magnetism. And same, you need the math background, you need the math 202 before you do this. And then physics 331 and 332, which is the spring course, are actual very special junior lab experience courses. And these are courses that turn you into a competent experimental physicist, such that in your senior year, you could, if you wanted, do an experimental physics thesis in your senior year, like a full year research project in something experimental physics. And so these are actually, I think, just, think of Reed compared to other places, this full year of junior lab at the depth we do it, because you've had lab first year, the full first year, the full second year associated with those courses. it's more in depth than I had at an Ivy League school as an undergrad. It's a really special thing that Reed has, that the lab is so involved in the junior year that you really sort of get your own feet in a physics laboratory situation. So that's, you can almost consider that a full year course between the 331 and 332. And then that final physics required course is quantum mechanics, which a lot of people are often excited about. And you are well equipped by your junior spring to really tackle it as a true subject, not learning just baby quantum mechanics, but really tackling the real deal. And so that's the sort of required core courses. I see there's lots of questions coming up, but let me just finish a little bit. The senior year is when you will do your thesis, your senior thesis. Hopefully before that point, you find some research area, maybe that overlaps with a Reed faculty member, maybe that doesn't, that you would like to explore for that full year project. And then in your fourth year, you also have a lot of time to take our upper level physics electives. And we have a lot of these because we actually have a lot of physics majors compared to sort of other liberal arts schools. You'll find that we actually have a really healthy array of upper level electives that you might find at an R1 type school, overlapping, some of these topics would overlap with what the grad students take, but we're able to offer them here at Reed because we have such healthy enrollments in the physics major. So you'd be able to, in the classes, sort of feel out what way are you getting most interested. Another way that people figure out, because it can seem so intimidating, what do you mean I have to choose between solid state physics and thermal physics and astrophysics? What even are those? But over the course of your years leading up to the senior year, every single week, the physics department has physics seminar on Wednesdays, which is super well attended. And we bring in a research scientist from some research fields, right? And if you are welcome to attend those from your very first year. If you go to those frequently, then you start to get the feel of what's the landscape of current research in physics, right? Because right now it's really hard to tell. You'll get the very most popular science articles and kind of those break through to the common consciousness, but it's really hard to actually know where the landscape is in physics until you get that sort of exposure of individual researchers in, here's what I'm researching. Here's the borderline between knowledge and not knowledge in my particular subfield. So even though the choice might be hard in your senior year of what electives to take, you'll have some more information than you would have right now trying to decide what would I want to take. Cool. So Hui, do you think I should just keep going or should I tackle some of these questions while I have this up? What do you think?
I think, why don't you finish your thoughts and then we're going to have a question. We have a lot of good questions and we
that's okay.
A lot of time as well, but,
I'm not even looking, but I see the number increasing.
Yeah.
Okay, so I can always pop this slide back up if it's helpful for us later on. Oh, my mouse. There we go. Okay, stop share. Cool. So then let me just turn to some of the other things. I've spoken a little bit about sort of what makes our department different because it's probably on the top of some of your minds trying to decide Reed somewhere else. What do I do? So I think the things to highlight about our difference is the really healthy numbers. You're not going to be alone here as a physics major. We typically have at least 20 majors per year. And so that's great because you'll actually have a cohort of people. And among a group of 20, it's a lot more likely that there's some people that you really get along with and can make an even tighter cohort with and work on problems with and kind of make it a more fun endeavor going on this path of learning a lot of physics. So I think that's something that's really great about Reed Physics. Of course, the thesis is, it's Reed wide, but it's not always something that occurs at other colleges. And so to have that, experience of meeting weekly with a thesis advisor and working on some research project that you've helped come up with, either entirely. You are welcome to come up with your own thesis project, and we will, as long as it's physics, we'll figure out how to advise it. Who amongst the physics faculty is maybe most close to that field, or you're welcome to kind of come to our offices and talk to us about our own research, and we can help craft you a project within the umbrella of our own research. So for me, just to make things concrete, that's happened with two of my students this year. One of my students is working on data from the Sloan Digital Sky Survey, which includes spectroscopy of galaxies. And in particular, he's working on ways of figuring out what galaxies have two counter-rotating disks inside them. So like the disks move opposite to each other. Their stars are basically collisionless, so they don't actually run into each other. So it's a stable configuration, but he's sort of created algorithms to identify these galaxies in these data. And my other student has sort of gone into a completely different direction of looking at the magnetic fields within the disk of a nearby early type galaxy, and is studying how that might suppress the star formation, turning to the magnetic fields. So both of these projects were sort of under my umbrella. These students came to me and were interested in doing something astrophysics related. And so I sort of spun these projects their way, and they've taken them and run with them for the past year. And it's really fun to see what they've turned out with. We're sort of a month until thesis turn in, so they're nearly done. And then what else?
So Alison, can you talk a little bit more about like how do students get involved in this? I mean, like the thesis is definitely the culmination of like, you know, their time to read, and you know, it's a year-long research project. But even before that, like, you know, if they were interested in working in, you know, research with professors, you know, earlier than their senior years, how do they get involved, and how does that look like?
Yeah, so I mean, a lot of the effort is put into the senior year research. For opportunities earlier than senior year, the time really is the summer. That junior lab course is really working on the techniques of experimental physics that need to be developed before doing research in experimental physics. So it's very research adjacent for a course. But the summers are opportunities. Generally, the physics department will take about at minimum 5, but usually probably closer to 10 summer research students from Reed. And then we also encourage students to apply to, you know, particularly if they're interested in the subfield of physics that we don't have at Reed, to apply to research experiences at other institutions, either through formal programs or by reaching out to professors there, and to try to get experience in that subfield of interest that we just don't quite have at Reed. And so those are the two ways to think about, you know, summer research, both at Reed and us kind of helping to launch you to do it elsewhere. And then during the first 3 years worth of coursework, it's a lot about developing the skills that are just needed for physics research. Before a lot of those junior year courses are under your belt, it's just harder to be helping in a physics research lab or project for those that are more theory or observational based like me.
One of the advantages of like going to smaller rural colleges, you have this like very small classroom settings, you know, and access to your professors. And how do you say how accessible are like upper level electives, you know, in terms of like, you know, getting into them, getting access to professors, and actually how big are the intro classes? I know that when I took physics at my undergraduate, I'm a philosophy major, not a physics major, but I did my, you know, one physics science requirement. The class was like 200 freshmen. It was gigantic, taught by like 25 TAs. So what is like a first year class at Reed looks like in terms of size, and then like how do you get into like bigger class, bigger upper elective courses?
Yeah, sure. So for the first year course, it is taught as a big lecture. And so and this is similar to Chem and Bio at Reed. The lecture portion of the course could be 100 students in the fall. And so that's lecture 3 times a week. And it's broken down into smaller groups for both laboratory work and for what we call conference, which might be called recitation at other places, but it's small group problem solving. And the difference between a liberal arts college and a bigger school might be that it is led by your actual professors and not by a graduate student TA. And so it's really the people teaching the course or who have previously taught the course who are leading those conference sessions. And so you get that direct access. And sort of the conferences are at about 10 students to 15 students. So that's the size of the small sort of breakout portions of the intro year. Everyone has very open office hours. So students, I'm teaching the intro course for the spring right now, and students drop by my office all the time. And so please think that's a normal thing to do and a not demanding time of someone who doesn't want you there or something. Doors are very open for office hours. And then for the upper level courses, we can range from, at minimum, 5, although that's not very common, to more frequently sort of 15, 16 for the elective courses, so smallish. But because we have a lot of physics majors, there's actually a lot of your friends are in the course with you. So it's not a teeny situation, but it's a lot of other people that you by your senior year will know very well, and will be working with you on those hard problem sets in solid state physics or the second round of quantum mechanics. So yeah.
Absolutely. So we're getting a lot of questions about this topic. So I'm going to try to summarize it all in kind of 1 or 1.5 questions. Is like, if students come in with AP credits, like, for their AP physics, physics 2, or calculus, species, or if they have taken, community college classes or university classes elsewhere in linear algebra or multivariable calculus, are they allowed to skip those classes at Reed, or are they still recommended or required to take them at Reed?
Totally. And probably the sort of details of the questions would be worked out with your advisor. But broad brushstrokes for math credit, it'll be basically based on what the math department decides. If they decide that the coursework you've done or the AP classes you've done meet their requirement for calculus, then they will place you out of that. And we in the physics department sort of fully accept that. We don't question the maths department evaluation that either your prior coursework or your APs count for their math course. So we totally believe that. And then for physics placement, we don't accept the AP scores at all. What we do is give everyone a placement, everyone who's interested in placing out of Physics 101, just show up and we basically give you an exam that's very similar to the final for Physics 101. If you pass this, and actually like a little more stringent than pass, like you should have really good knowledge of Physics 101 if you're going to pass out of it. So you show up, you take this test, and if you pass out of it, you don't have to take it. And so it's pretty simple and pretty fair, because AP access is different for different people. And so we just have this one system. And if you know the material, then we don't need you to be in the colors. If there's things that you don't have fully dialed in that are in that first course, you may know a good half of it really well, but we'll still ask you to take the course.
And I'm going to add just one clarification, and Alison is right. We don't, take your AP physics or whatnot for your AP physics for your physics class, but we do give you credits, college credits in general for your AP courses. So it doesn't matter what AP classes you take like physics, calculus, history, art history, Latin or whatever. And each department have their own kind of like different interpretation of that. But overall, you do get credit as a reduction on the required classes you have to take at Reed. So just a quick clarification on that.
So yeah, it counts towards like the 30 credits required for graduation, but just may not count for getting you further ahead in the physics major.
Exactly. And so I know that for econ it's the same thing. You have to take the exam. If you pass it, then you get to go on ahead, just like physics. Another question that we've been getting a lot is just, you know, like what are some of the, you know, a lot of universities and colleges are known for like a certain kind of research. Like, if you want to do a certain kind of thing, you go to this school or that school, right? etc. And liberal arts is not like that kind of concentrated. What would be some kind of research, or what are the specialty that our professor at Reed, are working on or studying? And so if you can share that among, what are your colleagues teaching, or what are they pursuing?
Sure. Let's see. So I'm doing astrophysics. We have Mark Beck, who's doing quantum optics. We have Lucas Illing, who's doing nonlinear dynamics. We have Joel Franklin, who works in general relativity and theoretical field theories generally. We have Daryl Schroeder, who works on theoretical solid state physics. We have a new experimental solid state physicist starting with us next year, Jennifer. And we have two visiting professors who will be here for at least some portion of your time if you come here next year. Noah works on theoretical sort of statistical mechanics, which would be under the umbrella of thermal physics. And Aaron Cook, who works on sort of experimental atomic physics, is what the field would be. So we all have our own. And I'm leaving out John Essick, who has been part of the department for a long time, but is retiring and is sort of an experimental solid state physicist. And there's still his momentum and presence will be felt in the department for some time, but he won't be actually teaching anymore after this year.
Can you tell us a little bit about, like, again, this is a question that we get a lot, how flexible, how easy is it for a student who takes physics or even other STEM to maybe major in something else or study something, maybe not like major something, but like but still study something else that they have an interest in?
Take the courses you are interested in. So make sure, when you're evaluating, like, what should my major at Reed be? Maybe you've always been interested in physics and that's already decided. Maybe you're not. Always be deeply thinking, is this the path that is getting me into the courses that I am most interested in during my time at Reed? Because professors across the board are awesome at Reed. I wish I had the time to take all of the courses. You won't. You will have 4 years. You will have some time to take courses here and there outside of your major. I didn't try to, sort of fit in when those times are. A lot of them are in the first 2 years. Your senior year, you don't have to actually take physics electives. You could take totally things outside the physics department and still be a physics major. And so there is a range of courses from a minimum of 6 that one would take outside of physics and math to a maximum of, oh gosh, I don't know the maximum. I imagine it would be hard to fit in more than like 12 courses outside of math and physics. But be following your passions, be following what you find interesting, whether that's the specifics courses within physics, whether that's courses in, who knows, maybe you have a side interest in linguistics, maybe you have a side interest in psychology, whatever it is, philosophy, whatever it is, take those courses because you will be a richer human being afterwards. The professors are awesome, just so across the board here.
Fantastic. Let me. We have a lot of questions about, like, what do students do after Reed for their physics? Do you have a sense of where do our students go to for either graduate program or engineering, or what do they usually pursue after their time here?
Totally wide range of things. Some, probably about a third go fairly directly into, within a year or two, I would say, into graduate school, most frequently for physics, but sometimes for engineering. We do have people who go straight into teaching from Reed. We have people who go straight into working for just technical roles in different companies, whether it's some fraction of that is like really physics adjacent, like maybe going to companies that are doing quantum optics for hoping to like make real quantum computers, like work with quantum computing companies, to more like physics next door, not really adjacent, and just companies that want people who are good technical, quantitative people who can think well on their feet. And so just local employers, sort of like Intel, to further afield things like, just a startup in Vermont, one of my students went to. So definitely a range of things. We have one recent read, Graduate, was actually just featured in a White House like press briefing type thing on the future of nuclear fusion as a power source. And so she just graduated in 2020, and has found herself in sort of this intersection of policy work between physics and policy.
Absolutely. Alice, I don't know if you know anything about the nuclear reactors that you can speak on. This is also something that a lot of our students think about as well.
Cool, yeah, so the nuclear reactor is next door to the physics building. You will definitely have the opportunity to become involved with the nuclear reactor should you wish to. So it's a reactor, it just hums along. It's very, very safe. No one should worry about it. If anything goes wrong, you just bam, the fuel, everything goes down and the neutrons get absorbed and the reaction stops. Boom. It's like the easiest thing to kill possible. And it got, during the pandemic, there was just the NRC said kill it for a while, and the reactor sort of was not reacting. So it's the reactor program is a very active thing at Reed. You would become involved in it in your first or second year, and there is sort of a pretty intensive training throughout the year with, as I understand it, exams to become licensed to operate the reactor in the spring, and that's all external to any department. It is not run by the physics department. It is not run by the chemistry department. It is external to academic departments. It is sometimes used in research work. We've had physics theses, there's chemistry theses, there's biology theses that have used the reactor, its source of neutrons, in theses, but it is largely an extracurricular endeavor, although a quite time-intensive, science-intensive, and potentially sort of opening doors intensive. It does. We definitely have a higher fraction of readies go into, I wouldn't say like nuclear sector, but like nuclear things, whether it might be medical physics. I have a few advisees right now who are really interested in medical physics, because that is nuclear adjacent because you're often using radioisotopes to help with imaging. And so you need a lot of the same skills that you gain at the reactor, you need for medical physics. So it is a special thing at Reed, and if it's of interest to you, you should inquire more and figure out if you do come for a visit, if you want to go on a reactor tour or something else.
Absolutely. I'm a foodie. I love food, and every time I go to a restaurant, I always order everything. But I always ask, like, is it like a secret menu that they have, like that they don't usually share? So for physics, are there like, like, is it just what you show, or are there things that students can combine with other interests? Studying physics, but also like in their research, or other like, I asked like, is it like a hidden physics majors that we don't know about? Like anything like that.
I don't know if I'm gonna answer this question the way you intend, but there's things around the physics major that sort of exist that can be fun to get into. So I run there's a telescope on the roof of the physics building. So I train students and have open nights for anyone who wants to use the telescope. I also run a journal club for students who are just interested in learning a little bit more about astrophysics earlier on than the junior level course. And we also, in the physics department, I guess one of the extra things is that we actually employ a lot of our physics majors as in roles for just like student work jobs. And this is just such a total win-win, because one, a lot of students need jobs. We can pay them to do something, and we pay them to basically learn their physics better. If you're gonna grade for the intro physics course, or if you're gonna be one of the lab TAs for the intro physics course, you are there both earning money and just deepening the physics ideas that you're either grading for or lab TAing for. And so we every spring sort of put out a list of the jobs that we're interested in people applying to, and everyone who, I guess you don't even have to be a physics major, although we do usually choose physics majors for those roles, just because of that added payoff of deepening their physics knowledge.
And how easy or how accessible is it to, become a TA or work at the reactors, or, work with a professor?
So working at the reactor is really, it's all done through this training program there's a nuclear reactor director. There's 2 people who are staff people, but it's really largely run, the training, by other students, by students that have been working at the reactor for like 3 or 4 years. And I mean, they do only have a certain number of spots. And so there will be more people interested in the training than make it all the way through the training. I don't know exactly what that ratio is, but I know that, often it's the people who are most interested and most dedicated. If that level of excitement and dedication is there, those are the people who do like persist through the year of training. For student jobs in the physics department, we have an eye to whether we think it would be sort of helpful for the students who apply to it. But we have a lot of them. And so there's, definitely apply if it's something that's of interest to you. If you were struggling a lot in the same exact course you're asking to grade for, we might not take you to grade for that course. But as long as you have sort of solidly understood the course, you don't need to get like an A+ in it, but as long as you've solidly understood the material of the course, we're happy to have you as a grader.
Can you tell us a little bit about you mentioned this early in your introductions, but how does like conference learning work in a physics class? Like the lectures is easy, you sit and you listen, but like the non-lecture components, how does that work?
Yeah, so it's really problem solving based. So I'm the lecturer for the big intro physics course this spring. And so every week, probably actually, my conference problems for this week, every week I send out the conference problems to the other professors who are acting as conference leaders this semester, which is Mark Beck and John Essick. And we all have these conference problems, and so it'll be the same set of problems that we bring to the class, the conference class. We generally each start the conference with a little warm-up lecture to make sure you're not just diving into these problems totally cold and like, what were we learning again? But have us bring a little bit of the ideas to the forefront. And then we break into small groups. And we use a room that has chalkboards all around it, and students work in groups of 2 or 3 to solve the problems. And I try, it's better if I stay quiet and, let students mostly work through it on their own and just be there for guidance when someone gets really stuck or has like sort of an active question of like, why this way and not this way? Or I think there's 2 different ways of going this problem, and I can see both of them, but I really don't know which one to tackle. I can give guidance, but it's best if I'm actually pretty stand-backy and then just sort of go to the different groups when they ask for help.
And how does the grading work in physics?
I think it's, so Reed minimizes the focus on grades, but I think in the quantitative courses, you'll find things a little more familiar than sort of feedback on your papers. In humanities courses, we'll give you a grade on homeworks, we'll give you a grade on the quizzes. How that fits together in the whole picture of all the different pieces added up, we won't tell you unless you really ask, because we do try to keep the focus a little lower and more on the important thing is really to understand these ideas. The exact, like, did you get this point or that point for this, getting to like push that away a little bit and just be like, the important thing is if you understand the idea from the quiz. So if you come to me afterwards and we talk about some quiz you took and it's clear you understand the ideas, that's the important thing. The important thing is not the exact number on some piece of paper, but we do generally, score quizzes. We do generally score homeworks. And so you would be able to keep track. You could do the computation of like what grade you end up with at the end of the course if you really wanted to. I really, really recommend not putting any effort into that. It's totally a waste of your time. But the information would be there in the physics courses.
Any other question, guys? These are really, really good questions. So let me ask one question, maybe a little bit outside of just physics and more about just Reed in general. What is it that you love about Reed College and being a professor here for almost 10 years?
Yeah, well, what I love the most is getting to interact with people across the campus. And right, as everyone can imagine, living through the past 2 years, we've had a little bit less than that. Right, Reed did remarkably well. I'm super proud of us. I'm super proud of our students. We did remarkably well with the pandemic. We came back to, hybrid learning the first year and really fully normal operations this year, but still a little just dampens, like the open talks are, there's just not as many of them as sort of normal. Some departments are still doing virtual talks because seminar speakers didn't want to travel, right? And so one of the things I love the most is actually like talking with my colleagues across the campus in all sorts of different fields and just learning from them, whether it's over lunch in Commons. I totally go to Commons, like the dining hall. So I go to the dining hall, have good conversations over lunch, go to these open talks, whether it's in philosophy or political science, trying to unpack what's going on right now in maybe Ukraine, right? Like these really interesting things that keep me sort of a complete curious person are a part of what I love the most. As well as just learning. I guess I just love keeping learning, which I think is what you'd find from a lot of Reed professors. Part of the reason the culture here is that all professors go by their first name. And my take on why that is because we see ourselves as continual learners, just like you. So we have more experience, sure. We've been doing this for longer, and that makes us able to teach you certain things about these fields, and that's great. But we're not done ourselves. And what I like about Reed is it's a place I don't have to be done. I get to keep learning myself with the physics seminars pushing me into different subfields of physics I don't know everything about, or the campus-wide intellectual community.
Thank you. Can you speak anything you can about like the 3-2 engineering programs?
Yes. So they exist, and I think there will be an admissions event about them. True, Huey? Okay. So definitely attend that for more details. But in short detail, the programs exist, and you have to be very sure. Well, you have to make your choices about classes. You have to do a set pattern of courses, both first year, second year, and third year, in order to fit all the requirements in. It's pretty rigid. It's doable. The program exists. If you want to be an engineer, it can be a good thing to do. It is not the only way to become an engineer. We've had recently 3 students did, which was remarkable. It never happened that we had 3 in 1 year before, but we had 3 in 1 year last year. So they're actually in the first year of the 2 this year, starting on their engineering portion of their degree. And so that 1 demonstrates it's possible, and 2, I think they all 3 of them managed to get the required courses without doing coursework elsewhere over the summer or something, which is one of the ways that can make it a little bit easier. But it's it's there, it's possible. If you are sure about engineering, look into it, come to the admissions session on the 3-2 program specifically.
One other question about just, about PhDs, like how does Reed help prepare students who go into, graduate studies and things like that for physics?
Yeah, our undergraduate curriculum is really rich, and it's well regarded by PhD programs. And in particular, the fact that you will have done a serious research project in your senior year can give you a good leg up for PhD programs. They are competitive, not gonna lie, but particularly for readies who don't actually apply their senior year, but wait a year, they get recommendation letters from their thesis advisor that says this person can already operate as a physics researcher. And so you're not letting in some unknown quantity that it might work for them to do research or it might not. I can vouch for the fact that they worked independently and made progress in the final year of an undergraduate program. And so that is a strong thing that reedy physics majors have going for them applying to grad school.
Anything you can share about the mathematics and physics? So I think we have several questions about mathematics and physics major as well.
Totally. So a lot of folks, I was a double major in math and physics. Take the courses you're interested in your sophomore spring. And so in the first years, that's probably going to be the same set of courses anyway. Take the courses you're interested in sophomore spring, contemplate where your interests really lie. And you do not have to decide it is either physics or it is math. What you do have to decide is, well, you decide if it's one of those two, or if it's in the intersection of physics and math, what part of the intersection of physics and math are you interested in? Because at that point, you will design an interdisciplinary major that combines physics and math in the way you are interested in. So there's no longer a set program in a set interdisciplinary program in math and physics, because we found we'd created something, but it wasn't fitting all the different student interests in this intersection. And so if in your sophomore spring you find you are really interested in this intersection of math and physics, then work with both a physics professor and or a math professor to carve out, okay, what are the sets of courses in these two departments that really would set me up to write the thesis in this intersection that I'm most interested in. And so that's how it works. Double majors, you will be told, you can be told by me, you'll be told by other people, double majors are really extremely rare at Reed. And there's only one reason, and that's because the thesis, right? For an actual double major, you would have to write a thesis in the two separate fields. It is possible. It happens, I think, 1 to 3 students a year, right? Write two separate theses. One of the theses could occur in your junior year. One of the people I knew that was trying to do physics and philosophy wrote their physics thesis in their junior year. They then decided they actually didn't want to finish philosophy, and so didn't write a thesis in their senior year, but took a lot of physics electives, right? So this person decided not to be a double major in the end, but was sort of set up for it. I think I've known one student who was a math philosophy double major, and she wrote her 2 theses in the same year. But what you can and should do is take, if you're interested in both math and physics, we have a ton of physics majors who also take a ton of math courses, and other institutions, it would say double major. Do you need that on some piece of paper? Not really. When you go forth and explain to a grad school, I'm interested in mathematical physics, I've done this set of math courses, this set of physics courses, that's the important thing. The important thing isn't like the title on the piece of paper.
Thank you. Feel free to add more questions, guys. I see we have quite a few students here who are a fan of David Griffiths.
Cool. So Professor Griffiths is no longer teaching, he's retired. So he still sort of haunts around our department. He has an office. You'd see him show up at most seminars, but he is not teaching. You might get he sometimes fills in for us if we have to be away for a research meeting or something like that. So maybe, but he's definitely not sort of on the teaching roster year after year. He is great though. He is, if you have started to read his E&M book, he matches the personality shown in that book. And it's wonderful.
spoke with him, I think, one time in my first year working here. He's very delightful. And I was like, I want to pretend like I know what you're talking about, but like, I'm not. I have a question that a lot of students ask is like, Reed is known for being rigorous and it's known for being, very, intellectually charged. But, what are some things that students, should do to be successful at Reed as a student, and especially as a physics student, which is known for being, a challenging field study?
Yeah, I mean, I think, when do I see challenges arise? I mean, I think, right, physics is a field that it's really hard if you get behind to catch up. And so to just be diligent, to use your time well, plan when you're going to find the time to do the reading, to do the problem sets, and spend that time. Also try to budget the time to get enough good sleep, because that's when your brain makes the connections really happen that need to happen for true learning to occur. And so, yeah, I think, just steady, diligent work and decent enough time management that you get enough sleep are important things. Yeah, and I think also just recognizing that it is okay if it is hard. It was hard for me to come back after I did my PhD, I did 2 different postdocs, and then I came back to teach at Reed. And even some of the intro physics problems that were assigned, that I was doing them just to like be a good conference leader in the course, they were even hard for me. Some of them took me an hour. And I was like, I know this, I do this. And so there are times it will be hard, and it does not mean you can't do physics. And just to know that and be kind to yourself when those moments arise. And also I mean, people have had various experiences, various amounts of prior physics coursework going into the intro course, right? So the placement exam is there. We typically have 1 to 4 people pass out of it, out of probably 20 to 25 taking the test. And so it's pretty rare to pass out of the first year for the first course of physics, but that means that there are people that know 80% of the course material in the course, and there are people who have never ever seen it before. And just know, like, sort of have a clue that that range is there when you're talking with other people in the course. And if you're at the 80% level and stuff is easy for you, be kind and don't just be a show off. And if you're at the 0 and you're starting from 0 physics coursework prior, know that it is going to be harder than some other people. And it's not because you're necessarily bad at this or don't have the mind for it, but if someone's already done 80% of this stuff, it is going to be easier for them than it is for you. And so just be aware of that range if you're here with us next year.
We have a lot of good questions. Does anyone else have any other questions that we haven't answered so far about the physics? And okay, one final very random questions, Allison's. What is, if you have one, what is your favorite student clubs at Reed that is related to physics?
Favorite student club?
Or student activities that that your students do.
I mean, my favorite is the telescope because I'm an astrophysicist. So that's maybe easy. I already mentioned that. But yeah, it's there and it's fun. And the Portland, yeah, we are in Portland. For those of you who are more international and don't yet know about our weather, it's not actually super clear sky city. It's a pretty rainy city, particularly during the school year. But in general, we try to open the telescope sort of everything before fall break. And then after spring break, which is right now. And so we have sort of 2 periods where the telescope's more active. In between, it's too hard to count on, to even bet on any night being clear. It's openable by anyone who's trained to use the telescope during that time, but we don't try to have public observing during the rainy season here. And so I did see is the Yeah, it's absolutely undergrads. We don't have anything but undergrads here. And so, and it's even more experienced undergrads are largely the people who are doing the training. I also step in, I sort of rotate through, but it's often more experienced undergrad students who have learned how to use the telescope teaching new students how to use the telescope.
Are there research grants at Reed that students can apply to for their studies?
For work at Reed, for work elsewhere?
Either.
Yeah, for summer work at Reed, there's a few college-wide grants to apply to. We also have funding in the physics department. So if we hire you, you will be paid at Reed to work with us on research for the summer. For grants exterior to Reed, there are what are called opportunity fellowships for the summer, which if you find a lab to work in or a person to work with outside of Reed, you can apply to these. I've had students that I've sort of written recommendation letters be super successful getting these because often they're, when they're motivated enough to find the lab in the first place, they can write a really strong application that I really want to do this. Please give me the money to make sure I can be paid over the summer to do it. And so those have worked out for a large number of, I guess my advisees are the people that I've mostly known to do it.
So yeah, so at Reed, we don't have any summer program like classes or anything like that. But a lot of our students do stay on campus to work and do research with different departments, things like that. That's one of the questions about campus during the summers. Anyone else with questions? All right. Well, if there's nothing else, thank you so much, everyone, to joining us. You have any links that we have answers, we will send you an email with those answers. So feel free to email us as well. I'm going to share with you the emails that you can reach us by. So if you want to ask questions to a physics students, we have several who are working in our admission office who'll be happy to answer your questions about physics and their experience here. Write at reedies.edu. Thank you, everyone, and thank you, Alison, for taking some time on her Saturday morning. Thank you, everyone from all over the country and all over the world as well for staying up late or early morning to join us. This will be on our YouTube. So if you have friends who couldn't join us, we will share with you the link once it's uploaded. Again, thank you so much, everyone. Have a good day.
For sure. See you all.